Significant figures are used to represent the precision of the instrument used to measure the value. Not always are you going to be making the measurements, so you have to be able to look at a number and see how many significant figures are present, which shows you the precision of the instrument used. When we do this, we have a mnemonic device that helps you. We use the map of the United States, and on the map of the United States, we know that the Pacific Ocean is here and the Atlantic Ocean is here. The Pacific Ocean is going to represent times when the decimal is present, and the Atlantic Ocean is going to represent times when the decimal is absent. So if I take a number like my first number here, 10,340, that number was measured by some instrument. We need to be able to look at what the precision of the instrument was, and the precision can be found by noticing that there is a decimal absent. Therefore, we can cover up or ignore any zero that is on the Atlantic side of the Pacific, or Atlantic side of the United States, or of the number. And so all digits that are remaining after that zero is ignored are considered significant. So this number has 1, 2, 3, 4 significant figures. This number is on the Atlantic side, decimal is absent, so this number has 4 significant figures. When the decimal is present, we have to do just the opposite, which would be 0.00210. Now I have a decimal present. With that decimal present, I have to look at what digits are significant, and all digits that are on the Pacific Ocean side of this decimal, or of this number, are not significant. So this one and this one are not significant. All other digits are. So 1, 2, 3 significant digits for that number. If I show one more example of that, I have the number 1.020. That has a decimal present again, so I would cover up any zeros on the Pacific Ocean side. I notice there are none in this number, and so this number has 1, 2, 3, 4 significant figures. If I want a number to be significant, or a digit to be significant, as in the number down here, 15,000. If I write the number 15,000 like that, we have a decimal absent, so the zeros on the Atlantic Ocean side are not significant, and so this number would only have 2 sig figs. But if my measuring instrument had a precision that was greater than 2 significant figures, I could put a decimal at the end, which would make all of the zeros significant, giving me 1, 2, 3, 4, 5 sig figs, or I could even put a line over any of the digits to make them significant. If I put it like this, it would have 4 significant figures. Try the last ones, pause the video, and see if you get the right answers. Here are the correct answers for the remaining problems. Now if I do calculations, I have to always go to the least precise measurement to get my answer. And so in my first problem here, my first measuring instrument that was used to get the 2.3 was precise to 2 significant figures. The number, or the device that was used to get this number, has 1, 2, 3, 4, 5, 6 significant figures. When I put these two numbers in my calculator, I get 10.3829. I only can be as precise as my least precise digit. Therefore, I can only have 2 significant figures. So I have to round this to 10. However, written like that, it only has 1 sig fig, so I put a zero or a decimal at the end, or a line over my 0. The same rule applies for division. When I'm dividing two numbers, like so. I would get a number 69.407. Again, I can only be as precise as my least precise measurement, which is 2, so this would round to 69. When it comes to adding and subtracting, you only can be as precise as your least precise place. In this case, I'm precise to the tenths, and this number I'm precise to the tens. So when I add this up, I get 219.5, but my first number here is not precise to the tenths or the ones. So I have to round it to the tens spot, and I would get 220. The same applies for subtraction. This is precise to the tenths. This is precise to the 10,000ths. When I subtract, I get 2.1368, but I only can be as precise as the least precise, which is the tenths, so this would round to 2.14.